Alrighty, so in the last video we looked at the first part of undetermined coefficients. We solved the homogeneous equation and then proposed a particular solution, like I showed right here. Now in this video, we're going to look at the full method of undetermined coefficients, where we then solve for the coefficients and then write out our new general solution. So, I say let's just go right into an example. I think that's the best way to show this. So for this one, we're going to do the same thing we did in the last video, right? Step 1 and 2 are exactly the same. So for step 1, we solve the homogeneous equation. So we set this equal to 0, right? For all of these problems, you always solve the homogeneous equation first. And that applies for all of second order. We're going to propose, I'll write everything out for the first example. Propose y equals e to the rt, y prime is equal to r e to the rt, y double prime is r squared e to the rt. Plug those in. We have r squared plus r minus 6 is equal to 0, right? I just canceled out the e to the rt's. So now we solve for r, right? Does this factor nicely? I believe it does, right? This would be r plus 3, r minus 2. So then r is equal to negative 3 and 2. Very nice, right? We have just a standard case for second order, right? C1 e to the negative 3t. So we write out our, remember, the general solution for the homogeneous equation would be this, right? And then, now this is step 1. We're done. Now, let's go to, we need this for later. Remember, when we go to step 4, we need y sub h and y sub p. So now for step 2, we need to propose our particular solution, where our g of t for this one is what? 12 e to the 3t plus 12 e to the minus 2t. So if you notice, this is a lot simpler than like the ones that were in the last video. Our g of t is a little bit smaller, because I would never want to solve the ones like we solved in the last video, and you'll see why in 1 minute. So now let's propose y sub p. So now remember, if you have an e to the 3t, all you do is write out a coefficient in front of it. And we have the same thing for this one over here. Right, and that's it. That's our y sub p. Pretty simple for this one. So now, this is where everything is going to become new. So now in step 3, we're going to solve for the coefficients. Now in this case, we have a and b. So when you solve for the coefficients, you're going to solve for y prime, yp prime, yp prime, yp double prime, and then substitute them back into the original. So back to the original equation. And then simplify and solve and equate. Simplify and equate QUATE and equate like terms. So now let's go ahead and do step 3. So we need yp prime and yp double prime. So here's yp prime. We're going to have, what, 3a e to the 3t minus 2b e to the negative 2t. Right? I just took the first derivative of this up here. Now, yp double prime, that's what, 9a e to the 3t plus 4b e to the negative 2t. Now let me just check those really quick. Yep, we're good. So now we have our yp prime, yp double prime. Now we're going to substitute those back into our original equation up here. So let me go ahead and copy this. We have y double prime, so I'm going to go down here. So 9, substitute 9a e to the 3t plus 4b e to the negative 2t plus y prime 3a e to the 3t minus 2b e to the minus 2t minus 6y. Y was a e to the 3t, so minus 6 a e to the 3t plus 6b e to the minus 2t. All of that equal to our g of t, right, which was 12 e to the 3t. Oh, it's right here. I have it right here. Plus 12 e to the minus 2t. Okay, now we've substituted everything in. Do we have any like terms? Well, let's see. This one, this one, this one, and that's it. So now we're going to simplify, and we also have this one, and this one. So let's simplify. 9 plus 3 is 12, minus 6 is 6. So 6 a e to the 3t. We have 4 minus 2 plus 6 is 2 is 8, I believe. Plus 8 b e to the minus 2t is equal to, and I'm just going to rewrite this part. Okay, let me make sure this is correct, what I have here. No, it's not. This term is not correct. 4 minus 2. Do I have a sign error here? I do have a sign error. Why do I have a sign error? Should it be minus 6? Let me see, where was I? Oh, it's minus 6y, so this should be minus right here. My bad. So then that's 4 minus 2, which is 2 minus 6, which would be negative 4. Okay, now we're good. So now I said simplify and equate like terms. So like terms, we're going to look at this part here, and this part, and this part, and this part. So then we look. We see that 6a is equal to 12. I should have did these in different colors, right? And minus 4b is equal to 12. Right? I equated this with this and this with this. If you remember back to calculus 2, when you're going through all of your techniques for integration and you do partial fraction decomp, if you learn partial fraction decomp the textbook way, this is the way that they do it. They equate the like terms and whatnot. There's also a shortcut way, but this is like the general way to do it. So if it's like the same thing as that, you can think of it. So anyways, a would then be 12 divided by 6 is 2, and b would be 12 divided by negative 4, which is negative 3. So here's my a, here's my b. Let's go back to our yp. Let me copy this. Now that we're here, we're going to substitute back in for here And for here, and we get y sub p is 2e to the 3t minus 3e to the minus 2t. So let's recap what we did so far. We solved the homogeneous equation for y sub h. We proposed our y sub p. We then solved for the coefficients a and b. And now we plug them back into our y sub p. Now all that's left is step 4, the general solution. So for the general solution, it's y is equal to y sub h plus y sub p. Now once again, if your textbook, like my textbook, used y sub h and y sub p, if you, which I just think of y sub h means h for homogeneous, p for particular. That's how I like to think of it. My textbook did that. Other textbooks use other things. Like they might use y sub c and y sub p because I believe that first general solution is called something that starts with a c. I'm forgetting the term at the moment. But this is the general, it's the same thing, right? So if we add those two together, let me go ahead and copy this. We're going to have c1 e to the minus 3t plus c2 e to the 2t, right? And then plus our y sub p, so plus 2e to the 3t, oops, minus 3e to the minus 2t. So this here would be our final solution. Okay, so this example problem wasn't too bad, but they can get fairly long, and I might have a long one in here. The next one's a little bit longer, yeah. The next one's a little longer. Okay, so number 5. So for number 5, we have step 1, homogeneous. Solve the homogeneous equation. I'm just going to go ahead, skip a few steps. Propose e to the rt, cross out the e to the rt's. R squared plus 2r is equal to 0. Pull out an r plus 2 is equal to 0. R is equal to 0, r is equal to negative 2. We come up here, propose our y sub h. We get c1 e to the minus 2t plus c2, because we had an e to the 0 here. This is just 1, so plus c2. Now that's step 1. This is our y sub h. Step 2, propose our y sub p, right? When our g of t is 3 plus 4 sine of 2t. One thing I forgot to mention in the last problem, I always forget this. When you propose, luckily we didn't need to do it for this one. But remember, you have to check, do any of these match any of these? And luckily for this one, they didn't, right? So I got lucky. We didn't have to multiply any t's in our YFP. But for this one, well, let me propose our y sub p first. So remember, whenever you have a number by itself, it just becomes a coefficient. Unless it's paired up with like a t squared or t cubed, that's a different story. But in this case, we're just going to have an a, that goes with the 3. And for the second term, we're going to have a b sine of 2t plus a c. Remember, a cosine has to go with a sine, and a sine has to go with a cosine. So plus c cosine of 2t. Let me just make sure that we're correct so far. I have not checked this yet. Yep. Now let's check. Does any of these match any of these? You're going to say yes. This matches this. So let's get rid of this one. Get rid of these two. I'm going to multiply this by a t. Now, does this match this? Or this? No, right? So now we're done. So let me make this black. So now this is our y sub p. Step 3. Solve coefficients. So we need to solve for a, b, and c. So let's go ahead and take yp prime and yp double prime. This would be a minus, no, plus plus 2b sine of 2t minus 2c sine, oh, sorry, this should be cosine, sine of 2t. Take the derivative again, the a is going to disappear now. Now we just have minus 4b sine of 2t minus 4c cosine of 2t. Let me just make sure that's correct. Yes. I just have, when I did it the other way, I have my b and c are flipped, but it doesn't matter. As long as they're in the right spots. Okay, so that might confuse me though when I look at my solution, but we'll be fine. I just have to remember that my b and c are flipped. Okay, so let's plug these in now for our original equation. So let me go ahead and copy this so I can see it. Let me do this. I can select this here and then pin it like this. So now we can see it up here. Okay. So we have y double prime, so minus 4b sine of 2t. Oh man. Minus 4c cosine of 2t plus 2y prime, so plus 2a plus 4b cosine of 2t minus 4c sine of 2t is equal to 3 plus 4 sine of 2t. Okay, I don't think we need this anymore. So now let's simplify. Do any terms match? I don't think so, right? I don't think we have any terms that match here. What we can do is we can combine this, 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 and this with each other. Let me do these in different colors. So this and those other two together. So we can combine them like this. So we can have, let's look at the signs first. So we have minus 4b minus 4c times sine of 2t plus 4b minus 4c cosine of 2t is equal to 3 plus 4 sine of 2t. Let me just make sure I'm on the right track here. Yes. So now we're going to look at, do any of, oh wait, I forgot the the plus 2a. Let me move this over. We have plus 2a is equal to 3 plus 4 sine of 2t. Okay, so now you're going to look. This matches this one, and this matches this kind here. So we're going to have three separate equations. And think of this like this. I wish I had more space here. Hold on. Let me see. Let me make this a little bit smaller here so I can just fit this in. And this here, let me get another color. This here is going to match with this 0 since we have nothing over there. That's how I like to think of it. So now if I write out these three equations, we're going to look at what's next to what I have colored. So minus 4b minus 4c is equal to 4. That's one equation. The next one, we have 4b minus 4c is equal to 0. We do not have a cosine term over here. Specifically, we don't have a cosine of 2t term over there. Now, we have this 2a, right? So 2a is equal to 3. Yep. So now we have these three equations right here. And a is really easy to solve for, right? A is equal to 3 halves. Now it's just a matter of solving these other two. So we have a system here. Now if you remember, if you call back to when I used Cramer's rule, you can use Cramer's rule. Or you can just use substitution, right? So I'll just do this one with substitution. And I'm going to incorporate Cramer's rule into variation of parameters. So I might make a separate Cramer's rule video, I'm not sure yet. Or I might do it with the variation of parameters video. So let's do this. Let's just do this with substitution for now. So let's see. So let's solve this one here for b. So if we have b would be equal to c in this case, right? So if b is equal to c, then we can plug c in over here. So minus 4c minus 4c is equal to 4. That's minus 8c is equal to 4. C is equal to negative 4 over 8, which is equal to negative 1/2. If c is equal to negative 1/2, then so is b, right? Because we know b equals c. So now we have our a and our c and our b. Let's go ahead and plug these back into our y sub p. So our y sub p, let me pin this. So pin. We're now, what step are we on? So that was 3. Yep, so now this is the end of this step. So y of p is equal to 3 halves times t plus minus 1/2, sorry. Oops. Sine of 2t plus minus 1/2 cosine of 2t. Don't need that anymore. Let me just make sure that this is correct. Yep, this is correct. This is our y sub p. So now we have our y sub h and our y sub p. Let's go back up here. Let's see what our y sub h is. Oops. Here's our y sub h. So now, step 4, the general solution. Y is equal to y sub h plus y sub p, which is equal to c1 e to the minus 2t plus c2 plus 3 halves t minus 1/2 sine of 2t minus 1/2 cosine of 2t. Kind of ran out of space there. This is our final answer. So once again, this problem hasn't been too bad, right? I have 2 more example problems to go through. Let me find my solution for this one. Okay. So this one looks a little bit longer. Oh wow. Oh wow. Actually, no, it's not too bad. Okay. So let's solve step 1. Let me get rid of this. So let's solve step 1. We have y double prime plus y is equal to 0, right? Solve the homogeneous equation. This would be propose e to the rt, plug them in, cancel out the e to the rt's. R squared plus r plus 1 is equal to 0. Oh, we're going to have complex for this one, right? So then r squared is equal to negative 1. R is equal to the square root plus or minus negative 1. This would tell us that we are going to have r equal to 0 plus or minus I. So then our y sub h, I'm going to use the shortcut for Euler's formula, right? We're just going to go ahead and write C1 E, this goes right here to the 0t, so this just becomes 1. I'm going to go ahead and just leave it like this, times a cosine or a sine, and this goes with this term here. We have a 1 here, so this just becomes t. Plus C2, same thing, sine of t. Okay, that is correct so far. So now let's go to our step 2. Let me just box this off so I know where it is. Step 2, propose y sub p when our g of t is 3 sine of 2t. Let me just do this actually. It'd be a lot easier if I just pin it to the side so we can then see it the entire time. Right? This way we can see the problem at all times. Okay. So, when our g of t, so I can make this bigger now. So our g of t is 3 sine of 2t plus t cosine of 2t. So let's propose our y sub p. So we have a sine, so we have a sine of 3t plus b, cosine has to go with the sine, cosine of 3t, plus, oh, this one is a bit longer, plus a first degree polynomial, right? That's what t corresponds to. So it's a plus a1 of t times oh, sorry, we are not on a, we are on c. Oh man, plus, yeah, this is a little bit longer, right? Plus, where was I? Plus d plus d1 of t times sine of 2t. Hold on, this is actually completely wrong. I just had a pause because I just came back. I just realized something. So I just wanted to make sure. So that was actually completely incorrect. I overlooked the fact that we have a 3 and a t, right? That together is a first degree polynomial, right? So we're gonna have something like this. We have a first degree polynomial times sine of 2t. And these sines and cosines just are going to follow with the with this here. So this is plus, this would be, I'll use b now, b plus b sub 1 of t times cosine of 2t. And this is it, right? I'm sorry, ignore everything I just said. I was confused as I was looking at the way I did it in my notes, and I wrote it really weird. But the first way I had it was actually the same thing, I'm pretty sure. You were still gonna, yeah. I don't know what I was doing there. A sine of 2t, I was right the first time, plus first degree polynomial times cosine. So we're gonna have b plus b sub 1 of t times cosine of 2t plus, but then I have extra terms. Hold on, give me 1 second, I'm confused. For some reason when I did it, I completely ignored this first part of g here for some reason. And I'm not sure why. Maybe it cancels, I don't know. But why would I ignore that? I'm not sure. Well, let me just keep going with this and see where it goes. So we have plus, because this definitely should be the correct way to do it. Be c plus c of 1 of t times sine 2t. For some reason, I don't have this first term here in my original solution. But anyways, let's see. So we have this. So now step 3. Solve for. No, this definitely can't be right because this sine of 2t term should not be in our final answer. I mean, unless a ends up being 0, then it would work. So let's just solve. Hopefully it works, because I'm heavily disagreeing with what I have for my answer on paper here. Okay, so we're going to solve for a, b, b1, c, and c1. Let me just remove these comments. That was confusing me. Okay, so let's see. So we're going to take the first derivative. This would be what? 2a cosine of 2t. I'm going to have to do this one without any help from my other one, because this is completely different now. Hopefully we get the right answer. Plus b cosine of 2t. Wait, why am I doing that? I'm going to go ahead and rewrite y of p first, just to make this a little bit easier to take the derivative. So I'm just distributing the sine and cosine in. So now when we take the derivative, it'll be a little bit simpler to write out. So 2a cosine of 2t plus 2b sine minus 2b sine of 2t. We have to do product rule, right? Oh man, so plus 2 plus 2 b1 t, so minus sine 2t plus b1 cosine of 2t Now the next term, c sine of 2t, that's just going to be plus 2c sine of 2t plus c1 of t. This would be plus 2c1 of t cosine of 2t plus c1 sine of 2t. Okay, so let me just check this. 2a cosine of 2t minus 2b sine of t minus 2bt sine of 2t plus b1 cosine 2t plus 2c cosine of 2t. Whoa, see, good thing I checked. Plus 2c1t cosine of 2t plus c1 sine of 2t. Yep, okay. All right, let's keep going. So now we need the second derivative of all of these. So you can see how this gets very long, right? Here, let me box these off. So we have this one. Y of p double prime would be negative 4. Let me highlight these so I don't make any mistakes. Negative 4 a sine of 2t minus 4b cosine of 2t. So I'm going to highlight the ones I did already. Yep, I agree with what I have. And then minus, oops, we have minus 4b1 of t cosine of 2t minus 2b1 sine of 2t. Yes. So now this term's done. Okay, next one. Minus 2b1 sine of 2t. So this one's done. Minus 4c sine of 2t. This one's done. Minus 4c1 t sine of 2t. This one is not done yet. Plus 2c1 cosine of 2t. Yep, I agree. And then we have plus 2c1 cosine of 2t. And that's done. So now let me just check. Minus 4a sine of 2t minus 2b cosine, minus 4b cosine of 2t, yep. Minus 4b1 t cosine of 2t, and then just without the t, yep. And then next term, negative 2b sine of 2t, yep. Minus 4c sine of 2t, yep. Minus 4c1 t, yep, I agree. And then same thing, but now without the t, yep. And then plus 2t, plus 2c1 cosine 2t, yep. Okay, I agree with everything we have here. This is quite something, isn't it? Now we have to plug these in, right? So we have to add y double prime to y, just to yp. So yp double prime plus y of p. Before I do anything, I'm trying to see if anything will cancel. These here combine. I'm gonna underline everything that would combine. C1 cosine, C1 cosine, C1 cosine, nope. Let me just go ahead and I'll painstakingly, I can actually, since I have a tablet, I can just do this, right? I can copy this all down, put it here, and then add y of p. So then I'll copy this down. I wish you can do this with paper, right? And then add this to this, basically. So this is our whole thing. Is equal to 3 sine of 2t plus t cosine of 2t. Now, well, we have to simplify, so let's see here. So these combine, obviously. What about c sine of 2t? C sine of 2t right here. These will combine. Anything else? Let's see. B cosine of 2t. B cosine 2t. B cosine 2t. What about C1t sine of 2t? C1t sine of 2t, C1t sine of 2t. That's it. Then we have A sine of 2t. So A sine of 2t and A sine of 2t. Am I missing any here? Yes, and we have these two that will combine. Let me make it that a different color. What didn't I use yet? Green? Like a orange? Yeah, let's use orange. This one? That's not orange. This one. And this one. And these last two that are there as well, right? So I need another color. Let's do pink. This one and this one will combine. So let's go ahead and combine all these. So let's do the yellow ones first. So we have -4 plus 1 would be, I don't need this anymore. That would be what? -3a sine of 2t. Now let's look at the, so now I'll cross out the ones I'm done with. Okay. Now let's look at the purple ones. So we have -4 plus 1 again. So -3b cosine of 2t. These ones are done. Orange, we have -4 plus 1 again. -3 b1 of t cosine of 2t. Let me put a line here so we know where it changes. Those are done. The pink ones, we have -2, -2, so that's -4 b1 sine of 2t. We're done with these. Red, we have -4 plus 1, so -3. We have a lot of -3s. Sine of 2t. Let me see if that's a common occurrence over here with my other one. Yes, it is actually. And we have a -4 and a +4. I might be onto something here. Okay, so, well, I just did the red ones, right? I forgot the C though. -3c. Okay, so those are done. The blue ones, we have -4 plus 1 again. It's another -3. Is that a C? What is that? A T? What? Oh, that's a T. Okay, yeah. -3 C1 T sine of 2t. So this is what I meant by these problems can get long, right? And this is all equal to 3 sine of 2t. This looks like it might be correct though. I just have an extra minus 3a sine 2t term compared to what I had over here. But I think what we're doing is so far so good. Plus t cosine of 2t. So now we're going to equate. We're going to look at this here and this here and see if they match anything. So let me do this one in green. So sine of 2t, sine of 2t. That's it. Oh, and this one here. And then we have this t cosine of 2t, just this one here. So the green ones, we're going to combine together. So minus 3a minus 4b1 minus 3c is equal to 3. And for the red ones, we're going to have minus 3b1 is equal to 1. I think we are doing well here. This looks, yes, this looks like it could be good. Let's keep going. We have one more equation. The ones that aren't highlighted, right? They go with 0. So we're gonna have, this is 1, this is 2. In the third equation, we're gonna have minus 3b. This is the ones that aren't highlighted. Minus 3c1 is equal to 0. Okay? Yes, I'm seeing that this is going to work out exactly how I wanted it to. I need another page. Let's see. Add page. B1 is easy to solve for, right? Negative 1/3. Very nice. So if we know what B1 is, we can plug that into here. So we have minus 3a minus, what does that be? Plus 4/3 minus 3c is equal to 3. This is not working out how I hoped it would. Okay, so I just realized this third equation is not correct. Because they both have, like, one's cosine of 2t, so it's going to be minus 3b is equal to 0, and we're also going to have minus 3c1 is equal to 0. So this is equation 3, this is equation 4. So then, in this case, b would be equal to 0, c1 would be equal to 0. The only issue here is that we have 2 unknowns here instead of 1. So I'm going to pause and see if I made a mistake somewhere and try and figure it out. Okay, so I've come to the consensus that we just weren't supposed to have this first term here. And I'm not entirely sure why. I'm honestly not entirely sure why. Let me pause again and try and figure that out. So it turns out I have in fact missed a case in the last video. I can't believe this. I did not know that this was a specific case. So apparently when you have a sine and a cosine together, you're going to conventionally treat them as, like, you're going to treat them together. So I was actually correct, like, in my thinking of when I combined the 3 and the t as like a polynomial. So we're going to treat them as it would be together. So we do completely remove this term here. So what my textbook says, I'll read it word for word here. If the non-homogeneous function involves both cosine and sine, it is usually convenient to treat these terms together, since each one individually may give rise to the same form of a particular solution. And then it gives an example of like the same thing we have here. So I was correct. So you do kind of treat this as like together, and then this would just be this. Okay. So in my last video, I did miss this case. That's why I was confused. So now what I'm going to do is I'm just going to remove all of these a terms. Anything that has a in it will disappear. So it's not a big change. Not a big change at all. So then this would just disappear. And then this would fix all of our problems, right? That would disappear. That would disappear. So now we can solve for C, right? So 3 minus 4/3. That would be what? 5/3. So C is equal to -5/9. Let me just double check that. Yep. So we have B1, B, C1, and C. So if we go back up to our y sub p now, man, I can't believe I missed a whole thing there. Let me see. So let me pin this, go down to here. So then y sub p is equal to, since b and c1 are 0, we're going to have b1 times t. So we have b1, which was -1/3, times t times cosine of 2t, plus c, which is -5/9. Sine of 2t. So then that's minus. And that's it, because the other terms would be 0, right? Because b is 0 and c1 is 0. So now we do our general solution, step 4. General solution. Y is equal to y sub h plus y sub p, which would be, let me see, what's our y sub h? C1 cosine, C2 sine. And then we just add y sub p. So plus -1/3 t cosine of 2t minus 5/9 sine of 2t. So this is the correct solution. I did do everything else right except for that one little term that we had extra. So yeah, just remember that is a special case, I guess, of when you have a sine and a cosine. I did not know this. Actually, I'm really curious now. Let me go back all the way back to here at my examples here. I don't think we had any of these cases here, did we? Cosine, cosine. Well, for this one it's different because you have an e to the t and an e to the 2. Those are two separate things. So this one was correct. We did this one correctly. That's just a sine, cosine, sine, sine. Yeah, so we never dealt with that situation. That's why I got confused. Okay, we have one more example problem to go through. This one shouldn't take as long. This one's a little bit easier, I think. So let me get 13. Yeah, this one won't take as long. Algebra is not as bad. And the proposition for y sub p is a lot easier, right? So for number 1, step 1, we have y double prime minus 2y prime plus y is equal to 0. Homogeneous, right? We have r squared minus 2r plus 1 is equal to 0, right? I proposed y equals e to the rt, take the first, second derivative, plug them in, cancel out the e to the rt's, and we're left with this. This factors out nicely. It looks like, yeah, it's repeated root. So then we're going to have r is equal to 1 with a multiplicity of 2. So then that tells us that our y sub h would be c1 e to the t plus c2 t e to the t. Remember, that's the little trick that we used when we had repeated roots. We could either use reduction of order to get that t, or we can use the shortcut method, which is this. Okay, so now that's step 1. Step 2, propose y sub p, wherein our g of t is t e to the t plus 4. And this is a IVP, by the way, so later on we're going to be able to solve for our c1 and c2. Which honestly you could do now if you wanted to, but I'll do it at the end. We can wait till the end to do it. Doesn't matter. Yeah, you can do it right now if you wanted to, I think. Let's wait till the end. So, let's propose. So y sub p, we have a first degree polynomial times e to the t plus b, right, for the 4. Let me just make sure that's correct before we go on. I'm second guessing myself on all of these now. Okay, so what I have so far is right, but now we have to check, does this or this match this or this? You're going to say yes. This matches that up there. Now, does this match either of them? You're going to say, yeah. Oh, we don't need this. You're going to say yes again. Well, this becomes t squared now. You add another t to it. Now, does that match anything? No. So now we're done. This is our y sub p so far. Now, step 3, solve for a, a1, and b. So let me rewrite y sub p. So a t squared e to the t plus a1 t cubed e to the t plus b. Take the first derivative. A t squared e to the t plus 2at e to the t plus a1 t cubed e to the t plus 3a1 t squared e to the t. And that's it. That b just becomes, oh, plus 1. Right. Excuse me. Let me just make sure that's correct. Plus 2. Oh, wait. No, not plus 1. It's not a t, right? It's a constant. It could be a 1, right? It just becomes 0. Yp double prime, we have 2a, let me just do this one first. A t squared e to the t plus 2a, what was I? Yeah, t e to the t. We're done with this term. Plus 2at e to the t plus 2a e to the t. This term's done. Plus a1 t cubed e to the t plus 3a1. Oh, not yet. Plus 3a1 t squared e to the t. Done with this term. Plus 6. No, I'll do this one first. 3a1 t squared e to the t plus 6a1 t e to the t. Okay. Oh, this is longer than I thought it was going to be. The algebra. Let me copy this down. I'll copy that too. Bruh. Okay. Pin. Make that bigger. Thank you. Oh, not that big. Let's see. We have y double prime Oh man. Well, I'll combine right now. So this and this combine. This and this combine. Let me remove that. A1, T, no. No. Okay, those are the only ones that combine, I think. So we're gonna have, yeah. So A, T squared, e to the T, plus 4AT, e to the T, plus 2A, e to the T, plus A1T cubed, e to the T, just making sure we're on the right track, plus 6 A1 T squared e to the T, plus 6 A1 T e to the T. Now minus 2y prime, so do any of these combine first of all? Nope. So minus 2AT squared e to the T minus 4AT e to the T minus 2 A1T, is that to the third, e to the T minus 6 A1T, I like this one, squared e to the T plus y, so plus, those don't combine at all, AT squared e to the T plus A1 T cubed e to the T plus B is all equal to TE to the T plus 4. Okay, let's combine now. So I noticed that we had this one and this one, and we have this one, this one, this one, this one. I think that's it. Yes, and then we have this one, T cubed, A1T cubed, A1T cubed, and we have another one. These two right here will just cancel out altogether, right? Minus 4 plus 4. Same thing with these two right here. These will just cancel out altogether, right? I believe that's it, right? That doesn't, yeah, that's it. So we're going to be left with, let's do the red ones first. So we have 1 minus 2 is negative AT squared e to the T. Let's do the one that's not grayed out. This one that's not colored, plus 2A e to the T. The purple ones, 1 minus 2 plus 1 is 0. So these completely cancel out. And then we're left with, I did the red ones, right? Oh wait, I forgot the plus 1 over here. These completely cancel out as well. Forget that term. And then we have plus b. Is that it? That's simplified really nicely if that's it. 6. We were left with 6AT e to the T. Did I miss? Oh yeah, I missed the green one. Okay. So plus 6A1 T e to the T plus B is equal to T e to the T plus 4. Now let me see if this is right. What's an AT? So we should have a something T e to the T. Yep. Something just. Yep. This is correct. This is correct what we have. Okay. this matches this, and this matches this. So the 2a is going to go with 0, right? Doesn't match anything. The 6a1 goes with 1. And the b, which is just, goes with the 4. Yep. So a is 0. A1 is 1/6. And b is 4. So we got these. Then our y sub p, let me go back up. A t squared e to the t, 0, plus a1 t cubed e to the t, plus b, and let me just make sure that's correct. Yep, and now we do our general solution, step 4. General solution. Y is equal to y sub h plus y sub p is equal to c1 e to the t plus c2 e to the t plus 1/6 t cubed e to the t plus 4. And I have actually lied before. You cannot solve the IVP just from y sub h. You have to solve out for this general solution first. So now step 5, IVP, where we know y of 0 is 1, y prime of 0 is 1. So that tells us that we need y prime. Y prime would be c1 e to the t plus c2 t e to the t plus c2 e to the t plus 1/6 t cubed e to the t plus 3/6 is 1/2 t squared e to the t plus nothing. Now let's do our y of 0 equals 1. This would be 0 is equal to c1 plus 0 plus 0 plus 0 plus 4. So c1 is equal to -4. Y prime of 0 is equal to 1. We get 1 equals c1 plus 0 plus c2 plus 0 plus 0. 1 is equal to c1 plus c2. c1 is -4. 5 is equal to c2. That is not correct. It's 4 apparently. C1 is -3. Did I do something wrong? -3. What? So that should be 3, not 4. Is my y sub p wrong? No, it's not. No, it's not. Oh, wait. This isn't 0. This is 1. This is 1. Yeah, -3. Okay. 1 minus 4 is -3. Then this would be -3. That would be 4. Okay. Plug them back in. Y is equal to -3 e to the t plus 4 t e to the t plus 4. Oh, wait, I'm looking at the wrong thing. Plus 1/6 t cubed e to the t plus, what was it, 1/2? No, just plus 4. Okay. And that's it. This is our final solution right here. So this was a bit of a long video, right? Maybe I should have split it up into different videos for different examples, but just remember, one key takeaway to take out of this video, back to this example, if you have a sine and a cosine together, you think of them as one. Okay? So you're only going to look at the 3 plus t times sine and a cosine. So it's a first degree polynomial times a sine and a cosine. That's the key main takeaway. Other than that, these problems are kind of ugly. This is a lot of algebra. But remember, if you write it out in steps like this, don't cram everything into one line. Use multiple lines to help make it write everything big so you can see everything. You could even combine lines. There's other tricks as well. You can just go right to here and just try and add them in your head, and then go down. Just some stuff to make it go faster. You don't have to write everything out every time. I mean, once you get good at it, you get good at it. But it's a lot of algebra. Differential equations is a lot of algebra. Alright, yeah, I hope you enjoyed the video. If you want me to do any more examples, let me know in the comments. I will gladly help with any other problems you have. And in the next video, we will look at variation of parameters.